Okay, now this is part 2 for Physical Science 201. Last section I was cut off unexpectedly and at here, and then went on further but it did not record. So let's continue from here we left off. So if you have 200 Newton force applied to the object being lifted by 1 meter up from ground, and then in 3 seconds, the power should be the work done in the unit time period. And then 200 Newton, which is kilogram meter square second over second square. And so that will be divided by 3 seconds, which is times 3 seconds. Now the 3 seconds move up to combine with the second being squared to give you 3 second time second being squared. That gives to you the second square become second cube. And then 200 divided by 3, that's be 66.7. Right, and since we know kilogram meter per meter square over per second cube, that's the unit we call what? We call watts. So watts. That's the answer for the second questions. All right, what's the power? The first question was this much work done to. That's 200 kilogram joule. 200 joules, right? Now that's the solution. That's the end of this problem. Now we have more problem. We can post it on the website later on, but or email you. But here we are about getting to the last concept in this chapter called motion. What is that? Is the momentum, all right? The momentum. Momentum, right? Now, what is momentum? Do we use this term in the regular routine life? Yes, we do. Sometimes you heard people say they have their small business just take off, but now it's gradually gain momentum. What gain momentum means, if it is a retail store, for instance, they have inventory, they order some stuff and they come into the inventory, and then was very in demand by the customer, so they come in the first day, the second day be half sold, third day be all gone, there's no inventory left. That's called a cash flow. The very fast cash flow to make more money in a short period of time. This is the momentum we call the business getting better, and it's a good business. There's no inventory you can hold, and anything coming anytime will be sold the next seconds. That's a very good business, right? It's not going to be stuck for the merchandise, cannot go anywhere, and then you have to take a loss, right? So that's called momentum. In the routine life we use that term. But here, the momentum representing any object with a mass, all right, in a motion with a certain velocity. In other words, if you have a momentum, you are able to move the 40 books, right? 40 books. And a very fast time, very fast speed, move from point A to point B 100 yards away, and then quickly finished. That 440 books has you have very high momentum to move those objects. So the object and move very fast, they have momentum as well. So that's the term. And here, so we say any object with mass, right? Of course with mass, right? In motion, right? At a certain velocity. Right? That's the definition for the momentum. So it is the momentum, we use a symbol for momentum called rule, and then we may put here as well momentum rule. Look like a 9, but it's not 9. It's a Greek letter, rule. And then equals the mass multiply the velocity, and then apparently we all know the unit for the momentum is going to be kilogram for the mass, and multiply what is velocity. The unit for velocity is lengths over time, right? So the lengths is going to be meter, so that's meter. Over time is going to be second. So that is the unit for momentum. Now, after we understand the definition of a momentum, then we are able to relate this quantity to another law of conservation. We have several law of conservation laws we introduced in the past. The first one we all know is the law of conservation of energy, right? Energy cannot be created or destroyed, can only be stored and then converted between different types, and that's the law of conservation of energy. And then the second law of conservation of mass, right? There's no mass can be lost, but will be always there in real time. So then we have to introduce the law of conservation of momentum. It states as there, if there's no external force, right, exists, if no external force applied to the moving object, the momentum of the object will be kept constant. But if you have the momentum being taken away by another object with mass, but then total momentum will have exactly the same as the momentum from each object, the sum of each object, right? So let's also continue. So the total amount, if more than one object with, let's use the top, right? If more than one object was individual amount of momentum, acting upon each other, the total amount of momentum will remain the same. The total amount of the momentum for all the moving objects will be remain the sum. The sum of the momentum will come from individual moving object. The total amount of momentum will be the sum of all these momentum add up. And the amount also of momentum from individual moving object can also be transferred, right? Transfer loyally, doesn't lose anything, all right? Transfer and then between other object. Alright. So if we put a mathematical term, the momentum for more than one object, they all moving with a certain velocity and mass, they have different individual amount of momentum, then the total amount of momentum for the group of objects will be the sum of individual momentum, which is add up, right? The rule for total equals rule 1 plus rule 2 plus rule 3 plus 2 rule n object, right? And then, so if that is valid, then the following should be also valid. So the m total, right? Or the, no, let's put this way. Let's put this way. And also equal the m1 v1 plus m2 v2 plus m3 v3 add all the way to m n v n, that will be valid. So if we understand this, then we are able to look into some example, see if we are able to figure out the concept and then solve some problems. Alright. Now let's pick up one of those problems in the pretest. Alright, the pretest. And the pretest, I think, is going to be, let's see, what is the, pretest on momentum. Let's see, we have, alright, number 22. Number 22. Number 22 on this page, I think it's page 9 of the pretest solution key, right? Number 22. It says a car of 60,000 kilograms traveling on a rail at a speed of 6 meters per second hit another car of 40,000 kilo and at rest on the rail. If the second car starts to travel at 6 meters per second after being hit, the speed of first car will be, of course, slow down, right? Lose some momentum to the second car, which is not moving, the first. And then, so let's see if we are able to solve this problem. All right, we got now. So we have to solve the problem as number 20, number 23, as a list we make, right? Number 22, and the list of known. Right? So you need the value of the mass of each object, which is 2 cards. So M1 is going to be 60,000 kilogram, and then M2 is going to be 40,000 kilogram. Now the moving card, the 60,000 kilo, has a velocity, right? The V1 is at the 6 meter per second. 6 meter per second. And of course the V2, now tell me, what is the V2? The velocity of the second car sitting on the rail doesn't move at rest. Of course it's 0, right? It's 0. It's 0, right? Now that's the beginning of this situation, and before the collision, right? Before the collision. Now, so then after collision, right? After collision, these two mass doesn't change. The velocity changed. The velocity V1 become unknown. We want to find out, so we don't know. But after hit, the second car started to move from 0 to what? To 6 meter per second. Oh, it moves just like the first car. So the V2, say, let's put, this is before, so that's a 2B. This 2A after collision, and that's 1A, after, that's a 1B, right? Before, right? So then the vehicle, or the car, the second car, set on the rail, start to move after being hit, is 6 meter per second. Now, according to the law of conservation of momentum right here, right, the total amount of momentum from these two cars, one is sitting down there at rest, the other one's moving 6 meters per second. The sum of these two should be the same before and after, right? That's law of conservation of momentum tells us. That's the law, right? Now then we are able to figure it out by set up the two before and after, the two totals, the total sum of the momentum. So let's say on the left is before, So the solution, right? Solution is right here, and the list of unknowns. Then before hit, the mass 1 multiply velocity 1 before. Right, the mass doesn't change, the velocity changes, so it's before and after, B and A, right? B and A. Add the mass 2 multiply velocity 2 before. Correct? Should it be equal the mass 1 and the velocity 1 after plus the mass 2 V2 after, right? Getting too close, getting a little bit too close. All right, so let me move this a little bit higher so it won't bother you from your view. So 2A, that's the beauty of erasable dry ink markers. Okay, now, so if we understand this, okay, so this is the situation. So, but here, before the hit, velocity 2 is what? Is 0, right? 0. So 0 right here. So this 0 times anything will be 0. This term is gone. Correct? Now, should we also plug in all these numbers into this equation at this moment? No. Why? Because that would be more complicated, because those terms, you become 0, you simplify already. Why you just put in, and then go to one more term is not really meaningful than 0, right? So you just simplify the equation first. First find the equation suitable for the problem, and then simplify the equation, and then unify the units, that's what I said, and then you plug in. So this sort of term is gone, and this is there, and then this is the velocity for the first car. We don't know, right? That's what but this is known. So now we are able to plug in some of the value. Mass 1 is 60,000, right? It's 60,000, right? Right, 10 minutes. So 60,000 kilogram, right? And then multiply, the velocity is what? 6 meters per second. And add a 0, so the 0 is gone. We put on there so it will remind you there's 0, right? Don't forget there is term, but it's just happened to be 0 because at the rest on the rail. The V1 60,000 kilo, but we do not know the velocity, so we keep the velocity V1 after as unknown with a symbol. Then you have add the vehicle 2, right? The car 2 have mass 40,000 kilogram, and multiply after being hit, become moving, and then 6 meters per second. So you have a 6 meters per second velocity for the second car. Now we have unknown right here, and on the right, of course, and then we are able to just move this second term to the left. We call shifting term. We've been talking about this so many times. So what we do is we do this. We do shifting terms. What are shifting terms? We make this whole term, right? And then move to this side and change the positive into negative, right? That will do. And then so you have this. So you have 60,000 kilogram times 6 meters per second, right? Subtract, because negative sign, right? Negative sign right here, negative sign, right? Subtract 40,000 kilogram, multiply, multiply 6 meters per second, right? Per seconds. But then you equal 60 kilogram on the other side. You did not touch it. Kilogram. Multiply the V1 after. Right? After. Right? This is before. This is before right here. 1B. That's 1A. We don't know. Now you what? You just cross divide. You cross divide. Right? You cross divide. You cross divide 60,000. So what happens? You just cross divide. Let's use another red. So cross divide 60,000 kilo down to this side underneath as the denominator. Now you have 60,000 kilo right here. Now we look at it. Can we cancel something? Yes, we do. What do we can cancel? Kilogram on top, as you factor them out, right? Kilogram and kilogram. So the kilogram cancels out. Kilogram cancels out, right? Kilogram cancels out. And then 60,000 minus 40,000, right? Right? And over 60,000. Can we cancel all these zeros? Top and bottom? Yes. So there's 4 zero cancel. Factor out 10,000 and then cancel all these 4 zeros right here. Right here. Now what happened? Let's use top of this board. Is simplified solution from the equation. So what we have here is this. So let's see, what do we have left? Is the 6 times 6 minus 4 times 6 over 6. Let's copy this. So 6 times 6, the inside still have meter per second, right? Seconds. And minus what? 4 times also 6 meter seconds. Now over, that's a numerator. Over 6, right? Over 6. Is there any units attached to it? No, because this 6 and this 6 and the 4, they used to be 40,000, 60,000, and the 0 all cancel each other top to bottom on the fraction, And the kilogram all cancel, so that's just a 6 down there. But then here will be V1A, the first vehicle or car, after hit the second one, it will be slowing down. Let's see how much it was slower than the first. Now look at this. Do we have anything to cancel as well? Yes, we do. Do we have to do all this for 24, 36 minus 24 over 6? No, we do not. Because this 6 cancel this 6 as well as this 6, correct? Because if you factor 6 out of parentheses, inside will be 6 minus 4, be 2, right? So this is gone, so denominator is gone, so that's 2. Then that's the answer. That is the answer, what? 6 minus 4 is 2, so 2 units the same, factor out, right? Factor out. 2 meter per second, that's the velocity for the first car after hit. That's the solution and the correct answer. We're done with that. Right? We're done with that. We're done with that. Alright, so if you don't understand, go review and view it again, and you will find out. Now, another example for my moment, this is a different story. Now this is one situation. One moving object hit another moving object without any momentum, which is 0 because it does not have velocity, right? Stand on rest on the rail. This is one situation. Then there's another situation. They're both moving, right? They're both moving. Like different or same velocity, but when they hit, they could, right? They could have two consequences. One is the one being hit speed up, or the other one slow down, or they both combine to have a combined moving velocity, and with the mass all add up, we become one object. So let's see if we have anything on the pretest, right? Pretest. All right, say number 21. Now that is quite funny problem made. It says along the production line, meatballs, right, of 2 ounces each, in exactly the same size, but covered with a sticky gravy shooting out of along the friction-free. There's no friction. Free or real, and then they go to the bowl and then piled up and then shipped to the restaurant, right? And the 2 balls stuck together with the gravy rest on the middle of the reel were hit by the 3rd ball, shot out at the speed of 0.05 meter per second. Then I'm asking these 3 balls combined. They both stuck because sticky gravy, and they move the same direction towards the end of a production line, but they stuck together will be a little slower velocity, right? And I ask you the speed of the 3 combined, the 3 balls combined, with what kind of velocity should be, right? So let's see. Number 21, I got 1.5 minutes, right? So number 21 says, we make a list, right? The answer, of course, the list of knowns, right? We always do that in physics, in science, we always do that. So the mass, right, for 1 equal mass 2 equal mass 3. The 3 ball have the same mass, equal what? Is that 2 ounces? Yes, 2 ounces. 2.0 ounce each, right? And then the velocity. The velocity is 3, right? The 3rd ball is 0.05 meter per second come out. And then the velocity 1 before is equal velocity 2 before hit equal 0, correct? Because the sit on the rail doesn't move. Now time's up. Let's see the solution, right? And then the answer for the solution, right? Let's move the solution down here. The answer, right? Let's put here answer, right? Answer